Okay, welcome back, guys. So in today's question, we know the tension in the cable that is connecting point A to B is 14 kilonewton, and we need to determine the unit vector N in the direction of T and use N to determine the scalar components of T. And from the question, we know that the point B is located at the center of the container top. So what we need to find in here is the unit vector NAB, which will be in the direction of the tension in the cable. And for that, all we need to do is to find the vector AB. And if we divide that by the magnitude of the vector AB, we can find the unit vector NAB or N in the question. So for this, all we need to do is to find AB, and for finding AB, we only need the coordinates of B and the coordinates of A, and if we subtract these two, we can find AB, and if we get AB, finding the magnitude of AB would be pretty easy, and all we need to do is to find the coordinates of A and B, and after that, we're good. So let's start with the B and see what we have for the X component of point B. So if we look at the figure, we'll see the X component of B will be the distance 5 meter plus the 9 meter plus 3 divided by 2, which is the side of the one of the sides of container. And from here we can find the X component of B. Let's move on to the Y. For Y, we'll have this time 16 plus 8 divided by 2, and we are dividing everything by 2 because we know the point B again is at the center of the container. And if we do that, we'll get Y component for B, and for Z, we only have the height of the container, which is 3, and that would be the Z components of B. So we have everything for the coordinates of point B, and if we calculate each of these, so from here we'll get 14 plus 1.5, which is 15.5, and here we have 20, and we know that that's already 3. So let's move on to the point A. So for X component of point A, we know that we are this distance in here, which we see, and we will be 5 meter in the positive direction for Y component. If we look at the Y component, we'll see that the Y component will be simply 12 for Y component of point A, and for Z we simply have 20 meter. Okay, and all of them are positive. So now that we have the coordinates of B and A, the rest of this is pretty easy. As I mentioned, our AB would be simply B minus A, and we just need to put that to find our unit vector N. So for AB, we'll have 15.5 minus 5. We have 20 minus 12 for J, and for Z, we have 3 minus 20. Um, and if we want to find the magnitude, we simply have a square root of x squared plus y squared plus z squared. So we'll be having here 15.5 minus 5 squared plus 12 minus 20 minus 12, which is 8 squared, plus 3 minus 20 squared, which is minus 17. And from here, for each of the components of n, we have to divide. So for example, if we want to find nx, we simply have 10.5 over the whole ratio that we have in here. Let's call this a. So this will be a, and y would be 8 divided by square root of a, and nz will be minus 17 divided by square root of a. And if we do that, we'll get 0.480a for x component of a unit vector. We'll get 0.372 for y component. We get minus 0.790 for, and that's our n. And if you want to show it in a vector form, we simply have each of these component, which is 488i plus minus 0.790k. So that's our unit vector. And for finding the tension using, so that was the first part of the question. In the second part of the question, we need to use n, the unit vector that we found, to find the scalar components of t. So if we want to find t, we simply have the unit vector times the magnitude of t. And from the question, we know the magnitude of t is 14 kilonewton. And that goes for the rest of the question. And if you want to find t, we'll have 14 times the unit vector, which was plus 0.372j minus 0.790k. And from here, we can find x. And from here, we can find x component of tension, y component, and same for the z component. So simply for x component, we have 14 times 488, which will be 6.83 kilonewton. Y will have 0.372, which will be 5.20 kilonewton. And last one we have minus 11.06 kilonewton. And that would be the answer for the second part of the question, which we need to find the scalar components of t based on our unit vector. That would be the final answer for this question, and see you guys next time.